Alright, I'm going to explain to you solar eclipses on paper. You know, it seems that this attracts more ASMR viewers anyway, so we're going to talk about the total solar eclipse happening on August 21st of 2017 over North America. Within my little diagram here, I have received the coordinates from Stellarium at different latitudes of the Earth. We have the celestial sphere in the center here. We have a sun glass sphere covering the sun, enveloping the sun. We have a moon glass sphere enveloping the moon. During the time of the eclipse, now if you're looking straight down, not just only during the time of the eclipse, but the sun and the moon are going to be spinning counterclockwise if this is north on the top here. Okay, so during the time of the eclipse, I believe it's at a particular time. I wrote it down somewhere here. 7:30 Universal Standard Time. We see at 44 degrees north latitude in North America the moon at a declination angle of 11.96. We also see the sun, obviously, if they're going to be lined up, at 11.96 at that latitude. Okay. However, if we're at the equator, we're going to see the moon at a different latitude, a different declination, that is. The sun will remain the same. The sun, whatever latitude you're at within the Earth, will remain the same declination. At this particular time, at this particular day, it will be 11.96. So the sun is this little dot right here. The dot that's closer to the celestial sphere. And the moon is the dot that's a little bit farther away from the celestial sphere. They're separated by glass. Because they're separated by glass, and because the sun is hot, the sun actually bulges out this glass all the time. And the glass actually expands when the sun is behind it. Well, actually, it's going to be behind it all the time, but when the sun goes away from that spot, that expansion is going to shrink back to its normal size. So that's why Eddington viewed the solar eclipse stars displaced as opposed when they were not seen during an eclipse. It's because the heat of the sun expanded the glass, bulged it out, and the refraction involved when you're looking down over here at the stars from the Earth during the time of the eclipse, they will spread out. Okay, so that's what's happening with that. That's easily solved. What I also wanted to talk about is that the moon, however, is going to have different declination angles at different latitudes. If we're at the equator, the moon is going to be seen at 12.68 degrees north. If we're at 12 degrees north latitude, the moon is going to be seen at 12.48 degrees. So because of that variation in declination of the moon, that is what causes the eclipse, the shadow of the moon, to be projected on any particular latitude within the Earth. At this particular latitude, 44 degrees, the sun and the moon are going to line up at 11.96. Okay, but when you're over here, the moon is actually higher. It's at 12.68. So this purple line indicates seeing the moon over here and seeing the sun over here. See how the moon is a little bit higher at that latitude? This works the same in the heliocentric model too. That's why the latitudes, the degrees work either way. What I did want to talk about, well, I also wanted to mention, we're operating here on bending light, obviously. So the light is always going to be emanating from the sun on a curve, and that's how we get the light hitting the moon. That's how we get the moon shadow casting forth upon the Earth, as well as the penumbra. And the moon are obviously, the sun and the moon are obviously very close to each other. That is also how we're getting the west to east movement of the moon shadow. So if this is North America over here, excuse me, we've got Mexico going like this and like that, Great Lakes over here, Alaska over here, like that. We're going to see as the sun and the moon go this way, They're very close to each other, and that's how it creates the reversal and the direction of the shadow. So as the moon, I wish I had two hands here, but my pinky is the sun, my index finger is the moon, okay? They're both going this way, but the sun is going a little bit faster. So the moon is starting out over here, and they're crossing over like that, okay? Like that, crossing. But they're very close to each other, and that's what causes the reversal in the shadow. So my moon is going to be projecting a shadow initially over here, but as the sun is faster, they're both going that way, the shadow gets cast down over there. It's all on a curve like that too, okay? So now that you understand that, we understand how the shadow starts over here and it goes that way. It goes eastward. Okay, now I just want to talk a little bit about the differences between my model and the heliocentric model of the sun and the moon. Let's compare and contrast the sun and the moon. Well, let's start with the heliocentric model first. Initially, we have different sizes of the sun and the moon being about 2,000 miles wide versus the sun being 864,000 miles wide, which equates to about 391 times larger than the moon. And happy coincidence-wise, they will tell you it's a happy coincidence. Extremely rare, but it's a happy coincidence. It's unprecedented as a coincidence how the sun and moon appear the same size in the sky, because the sun is allegedly 400 times farther away than the moon. That should raise a big red flag for you initially, okay? Next is obviously the different distances, or the vast extremities and the differences. We have 238,000 miles for the moon. We have 93 million miles away for the sun. Highly impractical, highly improbable. Let's talk about the sun too. They say it's a fusion. It creates nuclear fusion. It's a fusion reactor. The problem is that convection doesn't work that way. They say it's coming from the core and going up to the photosphere. If you watch Donald Scott's understanding his study of the sun, you'll get a better understanding how there are many impossibilities. The sun is also, he says that it's receiving its energy from some other source. Even Eric Dollar talks about that too. Big red flag there, that it's not a fusion reactor, no convention. He also talks about the solar wind must increase exponentially. Why? Because they claim it's 93 million miles away. That doesn't make any sense whatsoever. If you understand the sun is actually very close, we don't have to enhance the velocity of the solar wind. We can actually cause it to decrease, which is obviously the case. It makes much more sense. When energy is like emanating from a source, it's going to, entropy, it's going to decrease. And so that's why we have the solar wind decreasing with my model, okay? The solar corona is much too hot, and the corona is going to be outside. The photosphere is the surface of the sun. Let me look, why am I showing my face? The first surface of the sun is a photosphere, and then outside we have the corona, and this is up to 1 million times hotter than the surface of the sun. Why is that happening? Well, my model, I'll get to that, but it's actually hitting glass and it's splaying out. And it's also, much of the heat is actually going laterally on the sides like that. But anyway, go back to the helium model first. No connection of the lateral magnetic flux lines. That's a big problem for helioseismologists. They have these magnetic flux lines going out like this, but they're not reconnecting. They're not reconnecting. They say, oh, it's just going on infinitely, up to 4.5 billion years of time go on, and they just keep going. So there's no loop. There's no connection. No loop. When you have something magnetic, a magnet, obviously a bar magnet is going to connect. The north and south poles are going to connect, right? We have a connection here. We don't have a connection here. No connection. That's why this helio sun model is not realistic. Okay, the moon, problems with the moon. We have the moon illusion that's never been explained. I explain it perfectly if you understand that the moon is actually farther away from us, and the glass sky is enhancing the refraction of the moon, and also because when we look laterally to the horizon as opposed to looking up, we get more red light. Here's my purple pen. Somewhere around here. Oh well. But anyway, red light is faster red light is faster than violet. And so even though the moon is farther away physically at the horizon than at the zenith, the light reaches our eye faster, and it actually equalizes the angular size, the apparent angular size of the moon and the sun. Perfect divine illusion at play there. Okay, so back here, why the moon flat? Why is the moon flattened? It's like egg-shaped, they will tell you, and well, that explain it perfectly with the understanding that we're seeing the moon behind a negative refractive glass sphere, which is actually transposing the vicinity. The apogee and the perigee actually work conversely. When it's close, when the moon is actually physically close to us, it actually appears smaller in the sky, and conversely, when it's farther away, we would call that the apogee, but it's actually the perigee, and it actually enlarges because of the magnification of the negative refractive glass. And that also has to do with phase conjugation. Watch Dan Winter if you want to understand more about that. And wave coherence, phi ratio, octahedral symmetry. It all has to do with the fact that there is an octahedron in the center of the Earth. Okay, this is all making perfect sense. Okay, why the moon and the helium model? Why is there Lambertian illumination? Like during a full moon, the moon will appear kind of flat because there is no gradation of the shadows on the sides. And they'll say, well, the surface is Lambertian. Well, it makes more sense if the moon is actually being flooded with light on the anti-solar region, or the opposite illumination zone within, as the light from the sun. If this is the top and the moon is on the bottom here, and the celestial sphere is between us, the light bends around and it floods that illumination zone, that anti-solar illumination zone. That's why we get the flattening, the no radiation shadows of the moon. And also, why is tidal locking evident? Tidal locking, come on, really? The moon it's rotating, but we're only seeing the same side. And what you're gonna call it gravity is bullshit, guys. No, I don't even have to write that. It's bullshit. Ether is what's the true force. So big problems with this understanding of the sun and moon, as opposed to perfect, beautiful, harmonious coherence at play with my model. Okay, we got the same size. The sun and moon are actually literally physically the same size. Two halves of one sphere. Initially, somehow, I believe, with crystal field theory, if you watch my video about that, we have octahedral crystal field theory. We have the ligands converging in the center, and they create a spherical energy bubble. And so we have a north side and a south side. And so somehow they bifurcated. The sun and the moon, sun on top, moon on the bottom. They split, and they possibly shot up out to the north. Maybe they shot up both. Maybe they both shot up. Hold on. I'm not even showing my hand here. Maybe they both shot up the north apex, but if you watch, what's that guy's name? David LaPointe. He's got videos about the primer fields, and it actually is. There's good reason to believe that the sun and the moon are bowls. Okay, now he's got the bowls opposite each other, and it's creating this plasma energy of light here, but there's holes in the center of these bowls, and it creates this magnetism that shoots out projectiles, basically. So that's probably how the sun and the moon formed initially in the center of the Earth. If you understand crystal field theory, look into primer fields as well. Okay, so we got no rotation. There's no rotation of the sun and the moon, even though the sunspots appear to be rotating around the sun. If you understand, there's actually differential rotation, supposed rotation. The sunspots are supposedly rotating faster around the so-called equator of the sun than they are at the poles. Why is that happening? Because what's really going on here is that the sun is a half of a sphere. This is the back of the sun. It's dark, it's flat, and there's collimated light rays going across the diameter, and the sunspots are actually operating like a conveyor belt formation. You're going around like that. Just watch my video. I'll put the link in the description box. So it's like a conveyor belt. That's what's happening with the sun. The moon, we get, obviously, they call it libration. We think, oh yeah, that's showing that the moon is rotating. No, it's not showing the moon is rotating, because, as I said before, the moon is closer to us, and we get different readings of latitude and longitude as well. Wherever we are within the Earth, because the moon is closer to us, we're going to get different sides. We're going to see slightly different sides of the moon. And it's also possible, because the moon is circling around, it could be some kind of centripetal force that's actually cocking the moon. When it's farther away from us and closer to the center, it's actually going faster, and that's the opposite of what they tell you. But it's actually it grows in apparent size when it's closer to the center, and so we have a cocking this way as opposed to a cocking the other way, about 8 degrees each way, when it's in apogee versus perigee. So that's explained perfectly. Okay, we always see the front of the sun and mostly the front of the moon. It's just like I told you before, we see a little bit to the sides of the moon, the sun and the moon. And we're still, even though it's a half of a sphere, we're still only going to see the front side. Okay, through glass causing lensing, I explained how the bulging is happening. What Eddington and Einstein thought was the gravitational bullshit lensing. Well, it's actually real glass refracting lensing. The sun and moon are close to Earth and close to each other. That's how the lunar eclipses work. That's how the shadows go from west to east. Electromagnetic sun makes perfect sense. Now, you're going to watch my video. It's coming up. It's going to be ready in about a day or so. But I talk about how the magnetic, there's a connection here. Okay, we have the sun, we have the celestial sphere, we have the sun, we have the octahedron, we have the north side of the octahedron. The light is coming up, high arm. Okay, ran out of memory in the phone, so I had to delete a file. But I was talking about how there's an actual connection here, okay? We have the octahedron here, okay? We have the high arm of light shooting straight out from the top. We see that with the Seymour radar imagery, okay? It bends back down like that, and it plugs into the back of the sun. The flat back dark side of the sun. There's collimated light rays here, okay? That's where the sunlight splays out like that, okay? There's a glass sphere over here, and there's this menorah effect happening because there's actually a series of laminated glass here that's increasing the amount of refraction. And it bends out like that with the electromagnetism working as well. The moon sphere is here, and that's how we get the moon phases. That's how we get the extreme curvature of light, even though like a day after a new moon, if a new moon is over here, the moon is still going to be dark because the light is there's the glass sphere. The light is bending around. It's creating the menorah effect. Watch my video where I talk about the menorah effect. Okay, so this is what I'm talking about in my new video here. But I talk about how this light actually comes out like that, and it actually part of the light actually converges, and it creates this onion shape. So John Lennon glass onion. I mean, that's all. I don't know why I'm showing you this now. You should watch my video. You know what? Maybe I'll release this after I release my glass onion video. And so anyway, the light converges like that. Some of the light, other parts of the light, depending on what part of the roundness of the front side of the sun the light is coming from, it's going to bend out at different directions. So that's how it hits the moon. That's how it also goes out in the back, and it returns around like that. So we have this formation of light, kind of like a beetle, and we got the onion effect here. We got the dovetail joint here. Okay, and so it comes around like that, and obviously this side of the Earth is illuminated, so that light is not returning. It's getting cut off here. That termination line, right? You know, it's terminating here. But the light that is not terminating, where the angle of incidence is too obtuse, it returns around. It returns back, and it plugs back in. All the light plugs back into the celestial sphere. Remember the bent back tulips? You'll see that. Actually, you've already saw that because I'm not going to release this video until afterwards. But it's all returning. It's hitting the celestial sphere perpendicularly, okay? Lady Madonna trying to make ends meet, but she can't. There's a hole. Is that saying she's a whore? I don't know. But there's a hole there. So the light returns, okay? And now, if there's a primer field bowl thingamajigger here, you know, watch David LaPointe, his primer fields. We have two bowls with holes in them, right? Creating this plasma illumination zone. But also, he talks about inside the bowls, he calls it the containment dome. containment domes. That could be how the sun and moon were actually formed. So we have the sun on this side and the moon on that side. They're both bowls. And then they shot up. Remember he talks about how the magnets get shot up like that? Pew! Sun goes out through the top of the octahedron. The moon goes out through the bottom. That's how the sun and the moon were probably formed. Okay? And so, but we have a reconnection here. So the light gets, all the light goes back to the center. All the light returns back to the center through this primer field mechanism, and then the light gets shot up, back up to the north side of the octahedron, the north apex, the eye of the pyramid, and we complete the circuit. The circuit is complete like this. On the Helios side, there's no completion of the circuit. It doesn't work. This is what works. Also, I wanted to explain part one before I got cut off. I forgot to tell you that within the moon illusion, how it's explained in my model is because, like, if you look upside down 3 legs at the full moon at the horizon, that illusion is going to go away because the moon is actually inverted. It's literally inverted within my model. Okay, so if you're standing here and the moon is here, you're standing here and you're looking at the moon like that, obviously, if this side is up and this side becomes up, so it's an inversion happening. Okay, so there you go. This solidifies that my model is the most accurate model of the universe there is. Okay, there's no, this hands down, it's a slam dunk. Everything works perfectly resolved. So welcome to LSC Earth.